yeah, it was like, hi John, hi Derek.
I love John.
I don't know. What do you want? We were like friends for a short period of time.
Yes, the Fault in Our Stars.
Yeah, he's okay. He's okay. He does a lot of good in the world, but like he has every means to do so, and he should do more with it personally. That's what I think. He's afraid to take any stance that would like offend anybody, and he should just be honest.
Good morning.
Good morning. All right. So this thing is what we're doing for a warm up. Here it is. Not that, but that. Anyone want to explain their thought process? Don't give me the equation. Just tell me what's going on here. How do they see it? How do you see it? They, the people.
Looks like an X.
Looks like an X. Good start. It is an X. And what is happening to that X? Yeah, Michaela.
One square is being added on the sides up each time.
On each corner. Yeah. That's one way to look at it. How many corners are there? 4. So we're adding 4 squares each time. Which makes sense when you look at this, right? The next step, if we're adding 4 each time, should be 13. And indeed it is. Also, this is a fun counting exercise. Remember the dots? Like different ways to count? So here's what I'm going to do. I'm going to go 1, 2, 3, 4, 5, 6, 7, and I double that, subtract 1 because it's in the middle. 7 doubled is 14, minus 1 is 13. Checks out, right? That was fun. Anybody see it differently? I mean, yes, we are adding on 4 squares each time. It's 1 for every corner, but is there another way to think about this?
Up one right and up one left.
Yeah, that's another way. Up 1 and right, up 1 and left, etc. Right? It kind of feels like slope, right? Yeah. There's another way. Any other ways? Who's in an art class in here? So you guys should know better. 1 in each row. Column. I don't know. What have you? What do you see? Better question. Better question. What don't you see? Yeah.
Negative space. Like
Yes. This is a 3 by 3 square. How much do we subtract? 4. This is a 5 by 5 square. How much do we subtract here? We subtract 4 times 4, which is 16. This is a, take a guess, 3 by 3, 5 by 5. 7 by 7. How much are we subtracting here? Well, it's 4 plus 5, which is 9. So 9 times 4 is 36. Subtract 36. There's another way to think of it. More complicated way, I suppose, but a more interesting way, I think. Right? So we subtract 4 here. We subtract 16 here. And we subtract 36 here. We subtract 4 in the first step. We subtract 16 here. We subtract 36. How does that relate to n? Any ideas? No? Okay, fair enough. I won't make you work harder than you have to. Who's got the equation? What's the equation that makes this work? Probably the easiest way to come up with the equation is to think, okay, we add 4 each time.
X plus 4.
So x or n in this case, because n is the step, but that's fine, either way works, right? As long as we're consistent with our variables. So x or n plus 4. And the way we might write that is f of n, which you might remember from algebra a little bit. It's a function, something that has a single input. Well, actually it has a single input to one output, a 1-to-1 ratio. Meaning, you go to a vending machine, you press a button, something pops out. You don't press a button and like 3 things pop out, which is unfortunate, right? Functions aren't as fun as broken vending machines. But at least you know what you're getting, right? That's what functions are. So, the function of n, meaning what pops out, what the answer is, how many things are there, depends upon whatever n is plus 4. That's what you say. So if n is 1, we plug in 1, we get 5. If n is 2, we plug in 2 and get 9. Oh. If I plug in 2 for n, do I get 9? I get 6. This ain't it, Chief. What do we do? Anybody?
The previous one was 2 plus 4. So the one before plus 4.
Alright. I mean, that's what we described it as, right? Didn't you say it's like we take the x from before and we add 1 to each, right? We take the x from before, we add 1, we add x before, and we add 1, right? So how do we write that mathematically? Yeah, that's the question, right? I told you this is the output, right? F of the step we're talking about, the output of the step we're talking about. So we want to take the output, right, the last thing, of the step we're not talking about, but the step before, right? Well, if n is the step we're talking about, how would I write the step before?
N minus 1.
N minus 1. The step we're on, just back 1. So I want the output from the last step. And then I add 4. Let's try that. F of 1, we're going to set equal to 5. Because at some point we have to tell what the first step is, right? We can't just say keep looking at the last step, because there is no step before this, right? So you couldn't figure out what this is based on the last step, because there's no last step. So we have to say, look, f of 1, okay, it's 5. And we're starting at 5. Then we go to the next one, we add 4, right? So this says f of 2, meaning when n is 2, is going to be equal to f of, what's n for this one? What do we plug in? 2 minus 1 plus 4. What's 2 minus 1? 1. So it's going to be equal to f of 1 and then add 4. What is f of 1? 5. It's the previous step. Last guy add 4. What if we wanted to know step 3? Well, then we'd say, I want to know f of 3. That means I'm doing 3 minus 1. What's 3 minus 1?
2.
So I'm looking at f of 2 and then I'm adding 4. Look at f of 2, the step before, right? Add 4, you get the next step. That's the idea. Do you see how that works? We call this recursive because it goes back on itself. This is a popular term in computer programming where you look at the last step and do the next, right? Computers are super fast, so if they need to do 1,000,000 of those, look back, look forward, look back, look forward, they can do it, right? It's not as efficient as something more explicit that pops out an answer whenever you need it. But you can just keep looking back and to get yourself to look forward, which is, I think, a metaphor for life. Look back in the past, you not live there. But
But you don't know.
then you don't know thyself, right? If you don't know your past, how can you know your future? At some point, we have to go with what we're doing, right? It's beautiful. Put that away! Ah, sweet. YouTube has a new feature. We can create highlight videos. Put Zed in charge of that. All right, get out this thing. Does anybody need a new copy of these? Oh, what?
Whoa.
What's happened to us? Hi, Van. Oh, I know what it is. This thing's open still,
It's a high
and
quality
they're
camera.
both working. Okay, so like I have a document capture program, right? And then I have this, which I don't use the document capture anymore because I'm always live streaming. But they were both running at the same time, which I did not think was possible. That's amazing. Because now I can do like, okay, let's do it. All right, so here we are. Does anybody need an extra copy of this? How about you, Jenna?
I got it.
Wonderful. Lainey, are you having a good time?
Yeah.
Good.
The other camera's gone.
What?
Camera's gone.
Oh no. Where's my webcam? Why are you gone? Where'd my country gone? Should be here. Oh no.
No.
I know, guys. This is a big deal. Oh, it's not plugged in, I bet. I unplugged a bunch of stuff yesterday. This is what the people want, though. It's what they need. I have some bad news for all of you. You're not going to get what you want. You're not going to get what you need. No live cam today, sorry. No face cam. All right, so we talked about this last time. Y equals mx plus b and all that garbage. The front of your thing should look like this. Fool me once. All right. All right, guys. Thank you very much. Special delivery. It's your homework. Camera's not working at all, so we're just gonna have to shut her down. But it is on brain. Hit me. All right. Oh, check out that fade. Whew. Yeah, check out that fade. All right. So, y equals mx plus b is what we're rocking. Slope-intercept form. They call it slope-intercept form because it has the slope and the intercept. Which intercept? The y-intercept. I asked the questions. I missed it. Sorry. My comedic timing's a little bit off. We got to here-ish. We did some lines. You had to do some stuff. You guys didn't get past 5? Wow, this is truly my guinea pig class. All right, let's take a look at 6, 7, 8. Wow. Lies? Deceit? From amongst my own?
I was on the wrong page.
Betrayal? Go to the page with the dots. We want the one with the instructions. This one right here. That's what we're gonna take a gander at. So let's do it. And no one needs an extra copy. You all hung on to this? Okay, wonderful. Do we have any questions on the stuff before, actually? No? Wonderful, great, fantastic, amazing. So it says find the slope in the equation of the given line and then find the perpendicular slope to the given line. So first, find the slope in the equation of the given line. Well, there's the given line. Let's zoom in. Okay. What if I always sounded like that? Here's 2 nice points. And if I have those 2 points, I can find the equation of the line pretty easily, especially graphically. Visually, it's not that hard to figure out. I can go, look, between those points, I'm going up a certain amount, and I'm going over a certain amount. The question is, how far am I going? Well, it looks like I'm going to the right from here. 1, 2, 3, 4, 5. So that's 5 to the right. That's a plus, right? And I'm going 5 to the some number up, right? 1, 2, 3, 4. Oh, look, 5. That's convenient. So our slope is going to be the rise over the run for this guy. So the slope of the black line is going to be rise, 5, over the run, which is also 5, which means we can simplify this slope to be what? 1, or 1 over 1, or negative 1 over negative 1, right? Lots of different options. So our slope for this line is 1, which means the line's equation is going to be y equals 1x, or just x. It's up to you. That was a really nice one. That was a really, really nice one. Look at that. It's like perfectly horizontal. Spicy? Is that what we just said?
Yeah.
Is this spicy? Is that a proper... Cover your ears. I don't mean to insult you. Is that a proper use of spicy? No? Yes? You would say this is spicy? Like a spicy meatball, right? Fair enough. Who stole my spaghetti? This one. What's our y-intercept? 5. I only like jokes that are racist against white people. It's totally fine. Plus 5. Sorry, Italians. All right. So we have this. Bye, YouTube. What?
Can I have an eraser?
Because you want to erase that last comment from your memory? I don't have one of those. You can try. Here you go. Peters, I'll get you next time. So there's the equation of the black line. Y equals 1x plus 5 because we are at 5 here for our y-intercept, right? It's a regular y equals 1x slope, right? But we just moved it up 5. The entire line was shifted up. Remember that from Desmos, right? This number shifts up the line 5. Are we cool with that? So that's the y-intercept. Now we need to find the perpendicular slope that goes through this point. Perpendicular line that goes through this point. So let's choose, what color, what, Chloe, what color is this line going to be? Brown.
Brown never gets any love, so
Brown never gets you woke? What?
brown. No, brown doesn't get any love. So.
Doesn't get any love. That's true. Okay. I thought you were like making a really deep comment. I was like, Chloe, wow. Inspiration. All right. So check it out. This is brown. We're going to turn up the contrast here so we can actually see what's going on. Yeah, that's nice, right? It's like a nice milk chocolate. All right. So the slope for this line that we want is the perpendicular slope, right? That's what we're going to make through this point. So perpendicular slope is the complete opposite of the regular slope, right? It couldn't be more different. If it was the exact same, they'd be parallel, right? Two lines, right? Something like this, right? I'll never do that again. If we want perpendicular, we need a complete opposite. So we're going to flip it and negate it. So when I flip 1 over 1, I still get 1 over 1. But then I have to negate it. Is it positive or negative here? It's positive already, which means it's going to be negative when I negate it, right? Negate means change the sign. Doesn't mean make it negative, even though it sounds like it does. It means change the sign. So I have this kind of slope, which means our brown equation, our brown line, is going to be negative 1x. Not as good as the original one. And then we need to figure out what y-intercept this will be, right? So what will our y-intercept be if we have a slope of down 1 over 1? Well, if I go down 1 over 1, I've got this kind of line going through that point, right? Now that doesn't intersect the y-intercept, so I need to go the other direction. Now if I go down 1 to the right 1, what would I do if I wanted to go this way? I go up and to the left. Now that's okay because we know that this slope is the same if we do the negative up there or if we do the negative here. Whoops. Same dumb crap. Those are all the same thing. This one's the one where I go up 1 to the left 1. The same slope. And now you can see where it intersects. And it's going to hit it at 90 degrees because it's perpendicular, right? And we can see where our y-intercept is. What is our y-intercept here? At least I can see it. Can you see it? What's our y-intercept for the brown line? Hits the y-axis at what? What?
-1, 0, negative
Try again.
0, negative 1.
Try again.
You're frozen again.
No, I'm not. I think it's because this wire is faulty. Someone buy me new things.
Santa?
What?
Ask Santa.
Asks. Santa, go bye-bye. All right. The y-intercept is at positive 1 because it crosses the positive part of the y-axis. Zoom, zoom. Oh, I swear to God. Oh, my God. You are a piece of scumbag.
Oh, that's me. That's for your
Don't touch anything on this side. All right, so plus 1 is our y-intercept. So that's the equation of the perpendicular line. So if this is line L, then we could call this line perpendicular to L. I don't know. It's like using math symbols, making me look smart. Yeah! How do you feel about that? I know. Peters is bored. Not very good. Okay, so Jenna, we're going to figure out where things went wrong. Were we good with finding the slope of the first line? Okay, awesome. How about the equation of the first line? A little bit lost?
Yeah.
Okay, so do you see how 5 over 5 is the same thing as 1? So we're good there, right? That's the slope. The reason there's a 5 there, Jenna, is because the original line crosses the y-axis at 5. Remember, that's going to be our y-intercept. Okay, so that's where the 5 comes from.
Okay.
Now, to find the perpendicular line to that goes through this point, we need to define the perpendicular slope, the right angle to hit it at, right? And the angle is going to be negative 1 over 1, any way you want to write it. Okay? The reason for that is because it's this guy flipped, still 1 over 1, but the sign changed, negative. Okay? So we know that's going to be a minus 1. And we know this is a plus 1 because look where the brown line crosses. Now, how did I know where it crossed? Well, I used my slope, up 1, back 1, right? Positive 1, negative 1, right? to figure out where I'd cross. And I cross right there at 1. So that's why the 1's there. We feeling better?
Yes.
Okay, wonderful. Thank you for telling me, right? Again, was that something that was just mind-blowingly hard to understand? No, it wasn't, right? And I think you'd agree. But if you don't ask, it might as well have been, right? But if you ask, it's, okay, now we're good, right? Please ask. Please. Laney, are you okay?
It was a dumb question.
No, not a dumb question. It's an important question. It might be dumb, but it's still important.
I figured it
You what?
out. I figured it
Wonderful. That's perfect. All right, so next one. First of all, what kind of slope is that? Undefined, because it's vertical, right? We're going up infinity over 0 meaning divide by 0, meaning broken, right? Breaks math, undefined. So if we flip that, now the 0 is on top, right? So our perpendicular slope is going to be 0 over infinity, and 0 over anything, right? And 0 divided by anything is what? 0. So our slope is 0. What kind of line has a slope of 0? Horizontal line. That's right. T-pose. So, horizontal goes through that point. Okay, well, I can do that. Ta-da. What's the equation of the brown line? It's not going to be y equals, because if we have y equals, then we have a slope, right? And this doesn't have a slope, it's undefined. This is x equals something. See that all the points on this line have something in common? Like this point right here is x equals 1, 2, 3, 4, 5, 6, 7, comma 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice that this point down here is 7, comma 0. This is 7, comma 1, right? What do all these points have in common? 7, but like which variable is 7, x or y? X. So the equation of the black line is x equals 7. Because it says, I want all the points where x is 7. Does it say anything about y? No, because y can be anything, right? There's no relationship between x and y here. It's just x is always 7. There's the line. Now this equation, if you check all the points here, they have something else in common. What do these points on this line all have in common, the green line? The y is -2. So y is always -2. So we write it like that. Y is always -2. X has no relationship to y down here, right? X can be whatever you want. Y is just always -2. So that's the equation of that green line right there. So it's not good enough just to be like, okay, flip the slope, negate it, and do the thing, right? You have to actually think about what's going on here. This line represents all the points where x is 7. This one represents all the points where y is -2. Okay? We're going to come back to that. Turn the page. Nope. Hold on. I'm missing my spot here. Yeah, turn the page to where we have this. This guy right here. It's hard to tell, but the line is right there. Right over the axis. So the black line. Do you know where I'm at?
I might actually. Oh, I have it.
Okay, good.
My bad.
It's all good. Just missing one of the last pages. So this guy right here. All of the points on this line have what in common? For which variable, x or y? This is a tricky one. It's x, isn't it? X equals 0, right? If you're confused, pick a point, write it down. That's 0, comma 4. Down here is 0, comma -1. What do they have in common? X is 0, right? For vertical or horizontal lines, that's what you got to do. So the equation of the black line is x equals 0. The equation of the blue line that goes through this point and hits it at 90 degrees is going to be y equals something. What does y equal on this line? Y always equals 3. Is that cool? These can be really easy if you see it. If you don't, it can feel impossible. I've taught calc students that don't get this because they just don't remember. They're like, oh, yep, slope y equals mx plus b. And as soon as there's no y equals mx plus b, they're like, oh, right, we're screwed. Because they don't know how to think about it. They know how to do the formula. They don't know what it means. Do you see how I got this stuff? And if you don't, please tell me. I can help. Jenna, thank you.
No, I'm just wondering why you put the 0 and then the -1.
0, negative. Oh, here? So I said, if you aren't sure what's the same on this line, you can just pick 2 points on it, write out the coordinates, and you can look at it, can't you? Right? See how they both have zeros? I just chose that point randomly. I could have chosen another point down here, 0, -8 or something, right? I just noticed that, look, x's are always 0. That's what it is. So whenever you have a vertical or horizontal line, I would encourage you to do that. Yes?
How did you get the 3 again for the y?
Great question. So, in fact, the only question for this blue one, I think. So notice that this line right here, if I chose any point on it, all of those points are going to have something in common. They're going to have some x value, right? This case is like x something, I don't know, like 9, 8, or I don't know, I'm not going to count it. And then comma 3. This has a different x, comma 3. This has some other x, comma 3. This has some other x, comma 3, right? They all have 3 for the y value. Now, could I figure out what those x's are? Should. I could count, right? But I didn't want to, so I just wrote some random x. Okay? X is variable. It changes every time. Y is always the same, so y equals 3 for that line. That's all we know about it. Y is always 3. Okay? Normally, when we have an equation, like we did on this one back here, this is saying, here's the relationship between y and x. You take whatever x is, and you add 5 to it. That gets you y. There's a relationship there, right? They're connected somehow. Here, there is no connection. X is always 7. What's y? I couldn't tell you. It has nothing to do with x, right? All we know is that x is always 7. Y can be anything. Does that make sense? Okay. If I've got you at about 75% on that last little bit, we're doing okay. Let's look at the next one. We're back here now. So page 1 with all this, the one with the directions on it. I apologize for no page numbers or numbers for the questions. This was rookie Mr. Mac making this a couple years ago. Trying to recycle stuff, you know, Green Planet and all that. No Planet B. All right, so we need a line that's perpendicular to this guy. First of all, the slope of the black line, how can we figure that out? Pick 2 points, right? I'm going to pick 2 nice points. That looks like a nice point, and this looks like a nice point. You could pick any 2, though. Preferably pick ones that aren't like fractions. Do you know what I mean by that? Right? So we're going down 2 from this one. Again, you might start from the low point and go left however many and then up. It's going to be the same dumb crap, right? I'm just choosing to start from the high point and go low. When they go high, we go low, right? And then I'm going to the right from there. 1, 2, 3, 4, 5. So 5 to the right. Again, walk yourself from point to point and ask which direction you're taking. So our slope is -2 for the rise over +5 for the run. That can't be simplified, right? So we're good. That means our equation for the black line is going to be y equals -2 over 5x. That's our slope. The y-intercept for this, it's a fraction. How are we going to figure that out? Just guess? No. Here's what slope means. Another way to think of slope is that whenever we go to the right one, we're going down 2/5. Let me say it again. Whenever we go to the right one, we're going down 2/5. Think of it all together as one number, not a rise over a run. Take it all at once. So if I start here and go to the right, I've gone down 2/5. Do you see that? How I've gone down 2/5? So if I go to the right 2, how many fifths have I gone down? If I go to the right 1, I've gone down 2/5. How many fifths do I go down if I go to the right 2? You're ruining it! I had them! They were getting it. I'm going to say it again. If I go to the right 1, I go down 2/5. If I go to the right 2, I go down 4/5. If I go to the right 3, I've gone down 6/5. If I go to the right 4, I now go down 8/5. So my y-intercept is -8. Oh, it's gone down 8/5, I should say. So right now we're at 1, 2, 3, 4, right? We're at 4. That's where we started. And we went down 8/5 from there. Do you see what I'm saying? This dot right here was at 4 on the y-axis. and we went down 8/5 to get here. You smell what I'm stepping in? I'm here, which is at 4. Right? That's 4 on the y-axis. Well, I went down 8/5 to get there. You smell what I'm stepping in? So if I do 4 minus 8/5, that'll give me my y-intercept. I'm at 4, and I went down 8/5. Can I move it what? Over? Okay. How many fifths are in the number 4? I'll ask a better question. How many fifths are in the number 1? 5/5. How many fifths are in the number 2? How many fifths are in the number 3? How many fifths are in the number 4? 20 fifths. So we have 20 fifths minus 8 fifths. How many fifths does that leave over? 12 fifths. So our y-intercept is 12 fifths. Could you make that a mixed number? Sure, but why would you do extra work? Improper fractions are where it's at. This one's not an easy one, but it's doable. Let me walk you through what we did. I'm going to pause for station identification. I'm going to walk you through it. We're running out of time, I know. So I got a little bit. I found the slope. Is everybody good with finding the slope of the original line? Good. Thank you for the feedback. I really appreciate that. Good or bad, right? Positive or negative. So there's my slope. There's my mistake. Okay. Now I need to find my y-intercept, right? What number goes here? Where do I hit the y-axis? Well, I hit it right there, which is kind of a gross point, right? Right? It's kind of gross. So what we have to do is we have to figure it out using our slope. If I go over 1, I've gone down 2 fifths, because that's my slope, right? If I go over 2, I've gone down 4 fifths. If I go over 3, I've gone down 6 fifths. If I go over 4, now I'm on the y-axis. That's where I want to be. I've gone down 8 fifths. So I was at 4, right? That was my height originally. And I went down 8 fifths. So where did I hit? Well, I did whatever 4 minus 8 fifths is. That's where I hit, right? 12 fifths is where I hit it. A little bit more than 2. Right? And that checks out. Here's 1, here's 2, here's a little bit more than 2, 12 fifths. Are we feeling better about that? I don't want to hear 100% because I know that's asking a lot, but do we feel better about how I got that? Okay. So now the question is, when I make my new line, let's use red. My perpendicular slope, what's that going to be? What's my perpendicular slope going to be? Yeah, go ahead. Flip it and negate it. Negate means change the sign. So it was already negative, now we make it positive. Okay? So our slope for our perpendicular line is going to be 5/2. Okay. So I go from the point and I go up 5 over 2, yeah? 1, 2, 3, 4, 5 up, 2 over. 1, 2, 3, 4, 5 up, 2 over. And I can keep doing this, right, to make my line. I'm just going to use those dots. Are you with me? I went up 5 over 2 so I could make my line. And then I'm going to look at this and figure out what my y-intercept would be. Does anybody know what the y-intercept would be for this so I can write the equation? What is the y-intercept of the red line? Where does it hit the y-axis?
-5.
Yeah, it gives it to us, doesn't it? 1, 2, 3, 4, 5. That point they gave us is the y-intercept. So -5. That was much easier. Now the point of intersection for those two lines, that's a little bit grosser. But you could figure that out using the same method that we used before, right? Using slope. It'd just be gross. Here's what I want. I want you to finish this up. Okay? Tomorrow, we're going to do this, but algebraically. Right now we're doing it graphically, right? We're using the point they gave us and counting up and over to figure out what the line's going to look like, and then using what the line looks like, the graphic, right? To figure out what the y-intercept is. Tomorrow, we're going to do it algebraically. We're going to talk about a form of the equation of a line. We already know about slope-intercept, right? we're gonna talk about point slope form, meaning that if you give me a point and the slope, I can give you the equation, which is what they're doing, right? They're giving us a point and they want us to use the slope, the perpendicular slope, right? So we're gonna figure that out algebraically. It's gonna be a little weird, but it's gonna be okay. And I think you'll actually like it better because it doesn't require you to have to do that weird fraction counting thing that we did, okay? It gives you it automatically. That's the power of algebra. They're interconnected. Sometimes algebra wins, sometimes geometry wins, okay? Cool. This is awesome, isn't it? Dope as hell. All right. Looks like, anybody watch Full House?
Yeah.
Looks like DJ Tanner's like bedroom wallpaper,
Yeah.
like from when she and Stephanie shared a room. Ha. Wow. Yeah.
Here's your erase.
I swear to God, if you hit this and okay. All right. Thank you very much. Were you able to erase that memory from your mind?
Yes.
A little Pensieve action, right? Harry Potter reference. That's all I got for you for today. Again, best of luck on that homework. If you need help, watch the video. Okay. Try to knock that out. That we have plenty of time tomorrow to learn this last thing. Because tomorrow's Wednesday, my dudes. Thursday is our review day, which is also Halloween. Let's be honest, it's gonna be nuts. And then Friday is our mega quiz.
Oh,
We.
Right? It's got all this stuff plus the last 2 weeks on it. Go with God.
No, there's